And in this one, we are going to insert a video. There we go. Give or take, this is a good idea. You guys can see this? And why don't I do this? And this.
I think it's a great idea.
Slight flaw. There we go. Now you can see even more. That's good. Give or take, that's got everything it needs. All right. I feel like this is a pretty good, you guys can see kind of the page and the calculator, yeah? Okay, so yesterday we had already talked about this situation as being binomial. And we kind of said n was 5, p was 0.25. And we used the formula to calculate all these different probabilities. Okay? And like I said yesterday, we're going to learn calculator shortcuts today. That's what today's going to be all about. Okay? So, the first one I asked you guys to find was the probability that x equals 0. All right. Now, here's the deal about binomial distributions. They are a known, a predictable distribution if we know certain parameters, okay? The parameters, another fancy word for descriptor, the parameters are the two cardinal pieces of information that we know going into this. You guys, our two cardinal pieces of information are the 5 trials with a 0.25 probability of success. Is everybody with me? Okay? So, if we go into our calculators, and we're talking about a known, predictable distribution. Known and predictable distribution. Where do you think we should go? It's not normal, but if we went into trying to get to the normal distribution, like hit second vars, or to bring up the distribution menu, normal isn't the only thing in here. And in fact, if I start scrolling, there's lots of different known predictable distributions in my calculator. And all of a sudden, I'm beginning to see something that might make the binomial distribution easy to work with. Is everybody with me so far? So we are going to choose binom. For right now, we're going to choose PDF. Okay, when I choose binom PDF, it asks me for some information. The first thing it asks for is what's the n in the circumstances that we're dealing with? What is my n? 5. My number of trials was 5 trials. What was my probability of success for one of those trials? 0.25. Oh, and my x value? What probability am I trying to find if I'm trying to do the probability x equals 0? My x value would be 0. Everybody good? And if I hit enter? Hey guys, if I'm remembering correctly, yesterday we got it to be about 0.237. Is this okay? All right. What if instead I ask you what is the probability x is equal to 3? I would choose that binom PDF. Oh, I'm getting ahead of myself. And instead of my x value being 0, my x value would be 3. Is everybody good here? Oh, didn't we get 0.087 yesterday? Are we still good? Wait a minute. What if I said less than or equal to 3? And so, can someone remind me, what does x stand for in this case? Yeah, but in general, in this case, it's the number of kids who have type O blood. Okay? In general, X, my variable in this case, is my number of successes. Is everybody good? Okay? All right, so what is the probability of less than or equal to 3? Well, one way we could do that is we could say, what's the probability x equals 0 plus the probability x equals 1 plus the probability x equals 2 plus the probability x equals 3. We could add all of those up, yeah? That seems annoying, doesn't it? There was another thing in your menu, yes? Like if I go back to that distributions menu, I didn't just have binom PDF, I also had binom CDF. And if I chose that binom CDF on my screen, it looks the same. But let's go ahead and put these in. So we still have 5 trials. It's still 25% chance of success. And my x value is still 3, except for now it's less than or equal to 3. .984. So you guys see how it looks identical. PDF does strictly equal to. CDF does less than or equal to. How are we feeling about this? Do you guys see how that formula doesn't seem so bad when you can use this in the calculator?
Can you go through the steps on the calculator?
Just going into the distribution menu. And you scroll down until you get to either the scroll and get to binomial. And select it.
Oh, okay.
And then it's going to ask you for everything you need to tell it. Is everybody with me? Okay. Now, what's the general rule of thumb when using the calculator in this class? Whatever you have to tell the calculator, you need to tell to me. Okay. Somebody strong? Someone? BC's got me. I knew it would be you.
That shit was on.
I'm weak. You guys, it's almost like a Friday, so I'm allowed to have soda on almost Fridays. On non-school night dates, I'm allowed to have a soda. Because I'm allowed to have caffeine past noon. Because I have to get up early tomorrow. I don't have to get up until like 9:30 tomorrow. Guys, I'll be up at 6:40 at the absolute latest.
Tomorrow?
Yeah.
Without an alarm?
I got up at 5:55 without an alarm this morning.
Do you go to bed really early though? Okay, that makes a little more sense. I was like, how do you go with that?
I am getting ready for bed by 8 p.m. I'm usually asleep by 9.
Okay.
Wow.
That's still like 9 hours.
I went to bed one day last week and
I was in bed by 9.
Earlier this week, yesterday, because I went to bed at 8 o'clock on Sunday because I did a long run on Sunday and my legs were tired and like I was physically tired. So I fell asleep really early and yesterday I woke up at about 4:50 without my alarm. I got the puzzles done, I got the coffee made, I got lunches made for the week so I could just like chill this morning.
That's weird. Like that. Not like that, but like that's just like.
Hey, I like my day to be done at 3. I'd like to go home and just go to be like chill, watch TV. And when you're an adult with the responsibilities, like going home at 3 and just watching TV isn't like a thing unless you take care of those things in the morning. That's lovely. Hey, all right, so can we talk real quick about the work you need to show me if you're using your calculator? Because like before, could you just hit the normal distribution in your calculator and tell me the answer off your calculator without showing me anything else?
You had to show the graph,
You just show the graph. What did the graph communicate?
the shape, center, spread.
The graph, well, the graph itself showed me you chose normal, yes? And then your calculator asked you for the mean, so that got communicated by putting the mean on the graph, and then it asked you for the standard deviation, which is why you put the standard deviation on your graph, right? And then you shaded your graph to kind of explain what's going on. All right, so the equivalent to this for the binomial distribution is write the word binomial. That's how you tell me you use the binomial distribution. Then you're going to say n equals, p equals, because you have to tell your calculator that. And then you're going to write a probability statement like this one, where like this, that equal to communicates PDF. The less than or equal to communicates CDF. So your probability statement communicates to me which one you chose. Is everybody with me? So let's go through an example on the next page. I hope this is still recording. Oh, no, that'll be bad. Okay. And so what we... I never started it, so that might not have shown up on the previous page, but we'll have an example for those of you at home with this one. Okay. All right. You guys, go ahead and look at this one real quick. Does this look like it is binomial? Let's start with the first condition. It has to be binary. Is this binary in nature? Sure is. You either get the question correct or incorrect. Do we have a set number of trials? What is it?
4.
And we have the same probability of success and independence of trials. Does each trial have the same probability of success? And if so, what is it? Yes, it's 1/5, which is equal to 0.2. Okay. Now, you're not going to be asked, show that this is binomial. You're going to be given the situation and say, what is the probability that somebody gets exactly 3 answers correct on this quiz? Is everybody with me? So, the probability that x equals 3. Well, you're not allowed to just write that. You're going to say, well, I know that this is binomial, with n equaling 4 and p equaling 0.2. Then you write this probability statement. We're going to go into that binom CDF. So second vars to bring up the distribution menu, we're going to choose binom. Which one are we choosing for this one? PDF. So PDF will give you the probability x is equal to something. Okay? This time we have 4 trials, 0.2. X value is what? 3. Okay, and we get 0.0256. All good. All right, guys. What is the probability that someone gets less than or equal to 3 right on the test? Quiz, whatever you want to call this. How does this change what I do in my calculator? I have to use the CDF instead, yeah? Everybody good? So CDF gives me the probability x is less than or equal to something. And we just got to be really careful because as I look at this, other than the PDF or the CDF at the top, this looks identical. Yeah? Oh my goodness gracious. Did I do it right?
I think you put 5 instead of 4.
I think you're right. How about that? Does that feel better? I can't believe you guys let me make that mistake. It's all your fault. All right, you guys. Yes?
What if it's just greater than or
Wonderful question. Would you mind holding on to that for it's going to take me about 5 to 10 minutes to get to that, but I will address that question. If that's okay with you guys. Hey guys, what if I asked you what is the probability of somebody getting at least 4? Which, by the way, in this current situation, what does at least 4 really mean?
Wait, no.
Equals 4? Are you with me? Because can you do better than a 4 on this quiz? There are no outcomes that are greater than 4. So in this one instance, this greater than or equal to 4 and 4 are equivalent. Okay? Excuse me. So what is it? By the way, do you need to use the CDF?
You can use the P.
Okay. Do you need to use the binomial distribution in your calculator at all? Would you guys be comfortable saying this is equal to 4 is everything but the less than or equal to 3? So I could almost do 1 minus 0.9984 and get 0016. I am not trusting my arithmetic today.
That's right.
And Leo, we might have just started to lay the groundwork to the answer of your question. But there is a lot of nuance to it that we have to be very careful about. Are we feeling okay so far? Now, we are not going to do this. However, could we, and I can put this away for, I'm not going to worry about the calculator for right now. Okay. Could we take this exact same situation and say, well, what are my possible outcomes for scores on this quiz? Well, you could get 0 right, 1 right, 2 right, 3 right. And in fact, we know the probability of 3 is 0.0256, right? And 4 right. And we know that probability is 0.0016. And could we actually relatively quickly throw these other ones into that binomial PDF and come up with a probability distribution? Sure. It wouldn't be that hard, yeah? Now, because of that, could we find the mean of that probability distribution? Where we do 0 times its probability plus 1 times its probability plus 2 times its probability plus 3 times 0.0256. You guys remember doing this? Okay. And then the standard deviation of that would be like this big fancy formula where we do 0 minus something squared times the probability and so on and so forth. And I'm already irritated with this, right? We hated doing this work. Is everybody with me? And when it's not a known predictable distribution, that is what we have to do. But if something is a known predictable distribution, like, say, the binomial distribution, turns out there's formulas that can describe its mean and standard deviation. So the mean of any binomial distribution is n times p. The standard deviation of a binomial distribution is the square root of n p 1 minus p. They will look exactly like this on your formula sheet, and you will be given them. But it only applies to binomials. Is everybody okay with this? All right. Now, I want to spend a little bit of time, not a lot, but at least a little bit. Go ahead, stop. Talking about this independent same probability of success each time. All right, so let's go ahead and say I am the person that manufactures the dials that go on car radios. Okay? And I happen to know that 10% of those dials have some sort of defective property to them. Okay? this manufacturer is trying to say, hey, has it changed or not? Okay, like they've improved their process or something. So they're going to take a random sample of 10 out of 10,000 of these little dials thingies, okay? And so what I want us to, so if I take a random sample of 10, it's almost like each one I grab from the sample is a trial, yes? Okay? So is this binary? I grab the dial, I look at it, and I say, is this defective or not defective? Okay, so the binary is there. Do we have a set number of trials?
10.
Yeah, n equals 10. This is looking promising. As I select one of these dials and decide, is it defective or not, do I have the same probability of success each time?
It's 0.1, right?
Not if I'm pulling out of a sample of 10,000. What's the probability that the first one is defective?
Oh, because then it
It would be, well, how many defective would I have? 1,000, yeah?
1,000.
Is everybody with me? So 1,000 out of 10,000. After I pull that first dial, what's the probability the next one's defective? I'm all of a sudden drawing out of 9,999. Do you guys see what I'm seeing here? So technically, is this independent?
No.
Okay, now. We're going to play the what is the probability that none are defective. Okay, that's what we're going to find, which would be if we set P equal to 0.9 and define success as not being defective. Are you guys with me? Okay. And that would be the probability we get 10x equals 10 not defective parts, yeah? All right, so not binomial, so we can't do this binomially. So what we would do is kind of build this tree diagram, yeah? Which it's going to be obnoxious. But are you with me? We'd be on just like the top branch of the none are defective to get none are defective. Okay, so what is the probability that the first one is not defective? It would be 9,000 out of 10,000. And then what we would do is say, well, if we're saying none are defective, that first one wasn't, what's the probability that the next one is not defective? I had 9,000. I pulled one of the ones that wasn't defective out, right? It'd be 8,999 out of 9,999. Each of those will go down by 1. Times. It's the probability the next one isn't defective. 8,998 over 9,998. Is everybody with me so far? Now, guys, if I asked you to estimate the value of this fraction, what would you say? 0.8999999. And this one? 0.8999999. Are these really close to 0.9 still? Okay. And if I kept going, with a sample size of 10, my last one would be 8991 over 9991. Do you think that's still pretty darn close to 0.9? So while technically not independent, are we kind of okay with this? It's close enough, like even though that probability of success has changed ever so slightly, we're still probably okay with it. Is this okay? Under what circumstances would we be like, hey, this probability, it's when our sample size is too big. Okay, so let's say I had a sample size of 2,000 out of these 10,000. all of a sudden that last fraction, if my sample size was 2,000, it'd be 7,001 over 9,001. Now we're talking it's too far away. Do you guys see what I'm saying? So if my sample size is small enough, we can still assume independence even when it doesn't happen. And in fact, to calculate this probability by independence. There, that sort of says independence. Okay. To calculate this probability by hand is actually uber complicated in terms of, like, if we typed it into the calculator, the numbers get too big for the calculator to handle. Okay? Your calculators are smart, but they do have limits, and they can't calculate too large of numbers. Okay? Hey, so if I wanted to do this binomially, now we would do n equals 10, p equals 0.9. What is the probability we have x 10 successes? And we just throw this in the calculator to get this answer. And if I'm remembering correctly, I'll let you guys do this. It's essentially 0.9 to the 10th, yeah? It's roughly 0.348. You know what? I'm going to call it 0.3487. We still feeling okay? Okay. So, this next part, guys, I'm just going to do some practice thinking through the calculator stuff because there's a lot of nuance to this question, to using this stuff, okay? So, let's pretend we're going to go down to the gym and Miss Meister is going to take a basketball. She's going to shoot 10 free throws. Now, I think I've told you guys the story that when Meister played basketball, shooting the ball got her pulled out of the game. Every player has a role on the team. And Miss Meister's role on the team was not to shoot. My job was to break the press, because I have a low center of gravity, can dribble the ball really low, break the press, and assist other players in making baskets, and probably guard the other team's point guard. Cool? So let's go ahead and say when Miss Meister went to the free throw line, her probability of making it was 15%. Generous, you guys. Generous probability there. That's me being very optimistic. Everybody good? So my first question is, what is the probability that I make 2? This one's not a tricky one.
No, I know. I was just saying. I feel like there's like I know I can do it by calculator. I was saying like, could you just technically divide 0.15 by 3?
No.
Wait, no, that wouldn't work.
No, that wouldn't work at all.
Like you would,
You would have to say how many ways can I make 2 out of 10 times 0.15 to the second power times 0.85 to the 8th power. Is everybody with me? What's the answer? 0.27. Oh, 0.276 is fine. That's fine. 5.9 is fine. I just did that before. I only took it out to 4 before because I didn't actually round it off my calculator. I didn't want Leo to win. Cool? All right, you guys. What is the probability I make less than or equal to 2? Which outcomes are that, by the way?
that'd be
I could either make 0, or I could make 1, or I could make 2. I want to emphasize the way I said that. Which outcomes is this? Okay. What's the answer? 0.82. think you guys can be pretty confident that I'm not going to make more than 2, yeah? Hey, what's the probability I make less than 3? Which outcomes is this? 0, 1, and 2, yeah? So in a discrete variable, this is an important idea because this only applies because this is discrete. That's possibly why I emphasized this so much early on, yeah? In a discrete variable, the probability x is less than 3 is equivalent to the probability x is less than or equal to 2. Is this okay? So guys, what is the probability I make less than 5 shots? What are you going to type in the calculator? I don't have a less than in my calculator, so I got to rewrite this in a different way. Are you comfortable calling this less than or equal to 4? And then, since it's less than or equal to, you would choose binomial CDF, and just my x value would be 4 instead of my x value being 5. It's probably pretty high, I would think.
0.99.
0.99 what?
0, 1.
Okay, so literally 0.990. Okay, you guys ready for the trick question? What is the probability I make at least 5? No, I got it. 0.01. Hey guys. The greater than you have to, but we have to be really careful, okay? I want you to be really careful as we do this. So even though, yeah, we've already calculated this, which outcomes are not greater than or equal to 5? Which outcomes is that? Zero, 1, 2, 3, 4. So I'm going to do 1 minus the probability. Remember, if the CDF can only do less than or equal to, how do I describe these outcomes with a less than or equal to sign? We would say they're less than or equal to 4. So I could do, knowing that I just calculated that, it would in fact be 0.01. VC had it right. All right. What if I asked you, what is the probability x is bigger than 1? So anything with a greater than, we're going to have to say which ones are not greater than 1. So which outcomes are not greater than 1? 0 and 1. 1 is not greater than 1. So I'm going to do 1 minus the probability. That 0 and 1, y'all? How do I write that as a less than or equal to statement? Less than or equal to 1. Sure, I'm not actually that worried about what the answer is. I'm more like this 1 minus statement is really what I want to get to at this point. Okay, so I want to point something out. Here, this greater than or equal to 5, I subtracted less than or equal to 4, like this number changed. Whereas here, greater than 1, less than or equal to 1. So you want to ask yourself about that boundary point. Like, it needs to be included. So if I include it on my initial probability statement, I don't include it with what I'm subtracting. Am I including the one here? That means it needs to be included here. So Leo, does this answer that question of what if it's not less than or equal to? The answer is there's stuff that you just have to play around a little bit. And how do you think the College Board is going to ask you this question? These binomial questions, you think they'll give you a nice, easy less than or equal to? They're probably not. It's going to be something like one of these questions. So it's just something kind of keep in the back of your mind. All right. One more thing. This part's easy. Okay. Next week, Monday. we will be reviewing from before break. Wednesday, we're going to learn about something called geometric random variables. They are very, very similar to binomial random variables. Okay, very, very similar, but not quite the same. All right. Thursday, review. Friday, Unit 4, Part 2 test. There's only one more unit before the midterm. There will be no other tests before the midterm. There will not be a test over Unit 5. Unit 5 is going to be, I'm not even going to emphasize it on the midterm because of what it is. If I had to pick a unit not to give you guys a test, Unit 5 is the unit I would pick.
The midterm. Take the midterm.
You're going to take the midterm the Thursday and Friday before we leave for winter break.
And if it's not higher than the test score?
It doesn't hurt you at all.
Okay. That's what I was telling.
If it is higher than one test score, can we replace it with a test?
The way the midterm works is you automatically get the curve. And if your curved midterm score is higher than one of your test scores in the second 9 weeks, so that's Unit 3 or either of the Unit 4 tests, I will replace that test with your midterm grade. If it is not higher than your midterm, or than either of your test grades, nothing will happen to your grade. The goal of the midterm is to give people a way out of what is usually the three tests where people score the lowest. I.e., I don't know if you guys saw Unit 4, Part 1. Some of you struggled. Okay? It was a hard test. Okay? So it's to give you guys kind of some wiggle room there, but also to give you guys that experience of taking the cumulative test. Now, I don't have a ton of review time for the midterm. I don't have the time to do it. If you want to be reviewing for the midterm, you need to be doing that on your own time. I will always be here at 7:15 to help you. If you make an appointment with me, like you're going over old tests because you know you need to use it to replace one of your test grades, and you're going over old tests and you have questions, oh my gosh, I can't wait to help you. It's like my favorite part of the job is like working one-on-one with you guys. Okay? So I really, really, really want you to come in and ask me questions because for some of you really want that midterm to count for something. And I get that. But I don't have time to build that review time into class. You need to be putting in the time outside of class. Do you guys understand what I'm saying here? Now, if you are smart, you're not going to wait till Monday to start reviewing the stuff before Thanksgiving. If you're smart, you're not going to touch it until Saturday or Sunday. I would really like you to take tomorrow and Thursday and Friday to get a true rest. But if I were you guys, I'd be looking at some of the stuff from Unit 4 before Monday. But take these next 3 days that are vacation days, take it as a vacation. Take care of yourselves. Okay? Have fun. Relax. You guys, you can sleep all the way to 7:30 tomorrow if you want.
I feel like that's a ton of sleep.